Hi folks, another tutorial from me. It's Lothar from Germany. This time I will show you how to get G-code without a CAM program from a Grayscale image. This is a Grayscale image we produced in a Blender tutorial on how to make it, and now we want to make G-code for carving, Imagecarve and engraving this part. So you need a PNG 8-bit Grayscale image. And what the CAM? There is no CAM. Actually, it's just Imagecarve. Here, Imagecarve, where you get it from. Here's a big code. Oh, let's make it a little bigger here so you can see. Yeah, there we go. It's from Google Code RGFP Imagecarve. There's the file. I already downloaded that. Let's go down to, yeah, there we are. Here's the image, and here's the file from the site. Here you can download it here. It's the same file. I'm on Ubuntu, so I just click on it. The Arch is opening and I extract those 3 files inside. So here's the C file, here's the make file. The make file will work maybe on Windows, but here on Ubuntu it does not work that way. The README has an example how to use it. So on Ubuntu you need to have GCC installed, imagecarve.c, output file imagecarve with low mass. So open up a terminal. There we are in the terminal, and it's already on the folder. This screen, there are the files we need, and now get this line in, hit return, and you will see here this Imagecarve is now present in the folder, so we can use it. And in the help file and the README file you can get a quick example. Let's move it that way. Yeah, here a quick example on how to make G-code from a picture. I will now put this in, and oh, it just started. It already made the G-code. Here's output NGC. Let's see what it did. Copy it once together, gray highlight image PNG in order on PNG to PNM and PPM to PGM. PGM is the file format that the C file takes. Then use Imagecarve in the folder. Tool size 2 mm, step over 0.5 mm scale. That's the scale per pixel. It's 0.0416. That's the measurement. I would like to get 80 by 50 millimeters here. It's clear. The clearance height. The setup is from Blender order, and I have an offset because it's up. It's taller than 0 to the output NGC. So now open the NGC file here. As you see, there is no tool in, so it takes tool number 1 with the tool loaded. But on the first G1 we have to put F500 inside to get a speed, so Linux CNC does not get an error. So let's check this. Let's put it sideways. Let's open up Camotics. There we go. Camotics, our preferred simulation program. So let's remove this file. And I didn't know, but normally you can just put it inside. No, it's not gonna work. So open up no, cancel, add file, decode. Okay, output file. It's now in the thing here. The first one, it's a 2 millimeter. Let's say here 2 millimeter. Ball nose, save, and make it automatic move. So hit generate. Here's a progress bar. It says 16 seconds to calculate. 9 to go. Here you see it already has a quick decode. And let's see the outcome without the system. Here you see it's very rough, but it's time. We can go smarter with the numbers inside the file here. Let's close this one down, and here's, you can see, you can here make the step over more precise tool shape. And always where you can get information or help, join us on Linux CNC. It's on IRC chat. Server is Freenode. Join channel Linux CNC. There are other people who would like to help you. And see you for the next tutorial.